Everyone, settle down. All right, welcome to RITSEC. It is week on here? Oh, it's week 6. The week's not on here. Sign in if you haven't done that yet. Sign in.ritsec.club. We appreciate when you sign in. We have a resume bank, so sponsors want to get your resumes and they want to look through them. So make up a real impressive resume that's going to stand out and highlight all your skills. Upload it to the resume bank. I believe you can change the form. So if you update your resume, I think you can just go in there and change your submission.
Let me know if you do that because it does add a double submission. So I do need to go to the old one.
So just let Allison know. She can take care of that. Yeah, but get your resumes up there because sponsors they pay us money to get the resume bank and they want to see the resumes. So
you all have resumes now.
Yeah, and you all have resumes. Oh, shout out anyone. Did you get an interview or a job offer this week? Yeah. All right. Give a round of applause to everyone. Good job. How many of you is your first interview or your first job offer? Oh, wow. That's a lot. Good job, everyone. Good job. All right. So congratulations on that. We hope the career fair went well. If you still need any tips with interview advice, if you have follow-up interviews or you want resume review or anything, please let us know. We'd be glad to talk to you. Any questions you have for us, let us know. We've been getting some funny questions, but nothing really serious. I don't think anyone's not memeing. So let us know if you have any questions. All right, we have some sponsors here, and this is the first week we're putting them up, but these are the people that have officially gotten in with us. So we have IOMaxis and Ingressive, ReliaQuest, MITRE, and then Palo Alto Networks. So these are all platinum? No? No? 3 of them are platinum, and 1 of them's gold. Silver. All right, so ReliaQuest is silver, the rest of them are platinum, and hopefully we're going to get some more sponsors throughout the year, and that allows us to do things like our competitions for you. It's not cheap buying a bunch of servers and t-shirts and having you all in these renting rooms and everything. So this allows us to do a lot for you guys, and we really enjoy it, so we hope we can get some to keep up the good times. All right, this week, oh, one more thing, the HACS program. Who saw the post in competitions about the HACS program? So if you're not familiar with the HACS program it's kind of like our weekly meetings but stretched out over a month. So it's a collaboration of different schools. We're one of them. I think Penn State, George Mason, there's a whole bunch of them in there. And each month they create a challenge on a topic. So for example, the first month is Linux. Second month is going to be Windows. They're going to have networking, maybe CTF. There's just a bunch of different topics. Very similar to how we do it. We have a month to do them. So you can go ahead and hop on the scoreboard. There's a link in competitions. I think Jamie also posted it to the CTF, the Contagion group. So go and check that out. But if you just want to do some things, it's just finding the flags, just kind of like we do. And then when it's RIT's month, which I think is next month, you all just get the free flags because you're from the school. So you just kind of get to submit the flags for free and get the points for that. So don't miss up on that. It's going to be a lot of fun, good chance to learn if you're kind of thinking oh, I wish there was more of the weekly content, and it gives you a little more time to solve it as well. So check that out. Hope you enjoy it. And we're going to start our weekly demo, and this week is web. So we have our head of research here, Nick, going to be talking all about the web from what he learned from Heim.
Who's in another room right now? He's here.
Is he here?
Yeah, he's in the sec lab. He's just doing other things. Please hold. So, contrary to popular opinion, I do other things besides crypto. Yeah.
Fake news.
Fake news. Also occasionally do web. All right. So, welcome to the web. So, what is the web? Well, when people talk about the World Wide Web, they're really referencing this. Wow, that's a really strange definition. This interconnection of servers across routers and a bunch of different infrastructure that was set up over the years. I'm going to move on from this Wikipedia definition. So here's the key vocab that you're going to have to get on the down low in order to keep track of what's going on in the web sphere. So we got this HTTP, probably heard of it before, maybe seen it in the browser once or twice. That's just Hypertext Transfer Protocol. It's the language of web communication. So that's actually the underlying protocol that's used to communicate with a web server under the hood. And inside of HTTP responses are typically HTML, CSS, and JavaScript, which are other 3 little little dudes over here. There's a bunch of other things that can be put in there. But those are the three that we're going to start with. So HTML is a hypertext markup language, not a programming language, which is one of my pet peeves. So like, you know, on a resume and programming language section and you put HTML, I'm going to be like, okay. But I see what you're doing, but yeah, it's a markup language, not a programming language. It by itself is not able to do that much. In combination with CSS and modern versions of it, you can actually do quite a bit. So this is, HTML is actually like this manner that you're able to provide a structure to a web page. You're able to say like, oh, I want this button over here. And then like CSS is how you're going to say like, I want this button to look like this. And I want it to appear at this height in the, on the web stack. We'll get to that in a minute. So CSS stands for Cascading Style Sheets. By the name, you can see that it's basically about the style of the web page, how it looks, how it interacts. Fun little tidbit on the side for those following along at home. HTML5, which is like more current, and CSS3, which is also more current, together they can make what you can call a programming language because it's what's called Turing complete. Different topic, different time, but interesting little tidbit. JavaScript on the bottom. So this is like, they couldn't really, before this, the functionality I just said, which allows HTML5 and CSS3 together to do like anything you want. It's also really hard. They had to come up with like a scripting language to run in your browser because like, I want it to do fancy, cool stuff while people are clicking things, and like I want stuff to slide around. I want bubbles to like pop up, and you know, I want like, the marquee tag is nice if you guys know what the marquee tag is, but after a while it gets a little eh. So they have JavaScript. A lot of newcomers to the scenario might confuse it with Java. It's not Java, but it's the language of interactivity, not Webscale. Interactivity between you and your browser, I guess, or the browser in itself, or the browser and the server. I get it, interactivity. So yeah, those are like the main concepts of main high-level like friends in the web community. So talking about the basics of HTTP. So it's a layer 7 on the OSI model protocol. So that's the application layer. Everyone loves the OSI model. It's typically on port 80. It uses TCP as like its connection. And this is required because like you don't want to just like lose part of your web page when you're trying to connect to it, because that's not going to work very well. And that's why it's TCP, not UDP. Port 80 is just what we've assigned to it. If you're going to use HTTPS, which is basically the crypto-enhanced version of HTTP, so basically all of the communication is encrypted between you and the web server, then it's typically on port 443. Still through TCP though, because again, you don't want to lose half the web page that you're looking at. That wouldn't be great. And HTTP by itself is not stateful. It's stateless, which I'll explain what that is in a few minutes, but yeah, we'll get back to that. And there's a bunch of different types of HTML requests you can lodge at it. We call those HTTP methods. I'll have a little chart for those in the next slide, I think. And as well as when you get a response from a server, a web server, they're going to return you status codes, which tell you information about what the hell is going on, which again, I'll show you in a hot minute. Cool. So if you're going to make like your own little HTTP request, like you're on the terminal and you're like, all right, I got this, open up Netcat. You're like, I got to do this hardcore because I don't know, but I want to do it this way. So like, what the things that you're going to need to say what version of HTTP you're using. Different servers will be able to respond according to different HTTP versions. And then you need to say a path, so which part of the web server you want to access. So if you think about like in a URL, you might have like, so Google's a bad example, but like rit.edu, you might have like slash computing security slash index.html. That's not it, but that is a path, right? It's a path that's within the web root. so to speak. You can do some fancy stuff on the back end, so it's not actually the real path, but that's the path you're trying to request on the web server. And then you say the method, which we'll get to in a minute, but typical methods are get, post. Those are the big two. So you might be familiar with those or seen those in the past. If not, don't worry about it. And we'll get to headers and bodies in a minute. There's a lot on that slide. So here are the methods that we were talking about. So be aware, the two most common that you're going to see are going to be get and post. You'll occasionally see put and possibly head. Things that are dangerous are like options, as well as like, there's a ton of these that a lot of people say it's bad practice to use. That's why I say typically you're probably only going to see get and post. So what options does, which makes it kind of iffy, is that basically you're like, hey, web server, tell me what I can do. And then like it will just return to you all the different methods that you can use to access that endpoint, which is unnecessarily helpful. Like no one's doing that in 2018, except for people who are trying to find additional functionality which might not be as well vetted. So do you have a comment?
I disagree. It's used in APIs sometimes, especially for APIs that are currently being developed and expanded, and they want to have a thin client that doesn't need to have everything hard-coded. They do implement options there.
I could see it.
It's happened.
It's typically, yeah, I'm sure that a lot of things have happened. I'm sure that people are using like delete and like other stuff, but it's typically not great practice. But it is useful. I'll give you that. It can be useful. So like the rest of these columns tell you different things that you get from these. So like for example, head. Head is actually the same exact thing as get, except it does not return any content other than just the headers, which we'll get to the headers in a minute. But like a standard GET request, like you go to www.google.com, in your browser, you're sending a GET request to google.com server for the / path, and that's a GET request. It will return the body that has all the HTML and stuff to you. The head request would not. It would basically just send you like the status code, as well as other headers that you would receive, which we'll get to in a minute. So status codes, just talking about that. So status codes are typically segregated into these 5 sections. 100, 200, 300, 400, and 500 level responses. So 100 is typically informational. So like that could tell you information about the server itself, or as like your data's going. Not very common. 200, very common. 200 level responses. Those are typically indicating success. So like if you get a server status 200, that means that everything was okie dokie. Some servers, just a preface for all of this, some web servers or some things that people may program just don't even care about the status codes, and they'll always return a 200. It's not great, but that does happen, so be aware of that. Redirects for 300. So like this could be used for if you're moving from, say, one domain to another. Like you used to be googles.com, and now you're google.com, and you're like, people are still going to visit googles.com, and we don't want to just lose that traffic. So we're going to redirect, permanent redirect to google.com, and then, yeah?
Also HTTP to HTTP.
Yes, yeah. Yep. That was what I was just about to get that. Also, this is very, very commonly used for if you try to access a website on port 80 or HTTP, and we want to upgrade that to HTTPS. So that's another way to do that. You just redirect people to the HTTPS site. Number 400 is for client errors, so that's like your side. You sent something incorrect to the web server, either like on purpose or like the web app was pretty terribly programmed. But there's also some really cool memes in this section, like 418, which is saying, oh, you're a teapot. Or you say, I'm a teapot, technically. But cool memes. And then server errors is basically when the web server has a problem with either processing the request you sent or with back-end access to like a database or something. That would be a 500 error. Okay, these are the headers things that I'm talking about. So I was talking about before. So they provide some type of metadata behind doing the request response system between you and the web server. So typically these are in this key value syntax like we have here for like the request I'm sending, for, the content I want, so the request I'm sending to the web server, I'm expecting to get a content with the type application/JSON. So I'm expecting a JSON response, and then the server will hopefully respond with the same content type, and you'll be in agreement like this is JSON, this is not, say, text/HTML, because sometimes you want different types of contents, or it could be like, you know, like a zip, or it could be any number of things. Could be that content type. More or less is helpful for like MIME stuff, but a little bit out of scope for this. So that's kind of how headers work. There also, this is the section where like your cookies are going to be. So cookies, which I swear there's a slide eventually for these, have to do with like providing some level of statefulness to this otherwise stateless system that is HTTP. Because as you might have gathered, how HTTP works basically is that I'm lobbing requests at a web server, and they respond back to me a response. And in the request, like I mentioned earlier, you're going to have these headers, you're going to have the path, you're going to have all this stuff. And the only way that you're going to provide state, and state would be like, I'm on this page in the web server with this login, and I have these settings enabled, is through things like cookies, which are going to be passed back and forth between, well, are going to be passed to the web server and back when you're logging in initially and such. Cool. So like these headers also tell you about things to be able to like parse the actual content that you're receiving back, like how long the actual content is it cached? Did you get it from a cache, like a CDN of something, or like is the web server caching it itself? Different things like that, as well as like when you send the request, typically you send what's called a user agent, which is your browser. All of this stuff, you can literally write HTTP requests yourself. So all of these things are completely fudgeable, which is why it's exactly great, except for cookies, theoretically, which is why like it's not exactly great to rely on these things for security. Like if you're saying like only allow Firefox browsers to my website, and you're only processing the user agent, not a great security mechanism, because you can circumvent that really easily if you're relying on it for security needs. If it's functionality, that's understandable. So cookies, we're talking about cookies. So like I said, technically they're stored within the header, and they create state. So being able to like keep track of like where you are on a web page with what settings, with which user, all that stuff. Typically this could also be done partially on the JavaScript side, but if you're doing something that's not so JavaScript heavy, or like you don't necessarily want all of your state to be stored on the client side, you can do it with just cookies. And what a cookie is basically, it should be a random number that is passed back and forth between the client and server, like I mentioned before. It's important that that's random, so that way someone can't just guess the cookie, because in theory, actually we're talking about that later. Not going to talk about security just yet. Well, I guess I am, but yeah. So cookies are stored on the client in your web browser typically, or depending on the operating system, could be stored elsewhere. And you just kind of hold those and you send them per domain that you're connected to. So like my cookie for Facebook.com is not going to be sent to Google.com because they're origin specific. So you can, however, open that spectrum if you want and just send your cookies to everybody. Not advised. Definitely not advised. Not great. So like, especially if someone were able to like get your, we'll get to that in a minute. I'm getting ahead of myself. Okay, so the body, this is what I was talking about previously with like when you send a request, you're going to get a response, and the response is going to contain what's called the body. What that is basically all the data that you requested. So if you went to a web page, you're going to get back that HTML, that CSS, that JavaScript, all that lovely stuff that we talked about earlier. And then, like I mentioned previously, the head method will not return the body. It's the same as the get request. And some methods, when you're actually requesting, you send a body yourself, like post, and there's a few other ones, but post is the main one. So like when you're trying to upload data, if you think of it like that, right, to a website or a web server, you want to have that functionality where you can include a body. Typically that's a post request, but it can be other things. All right. Cool. So this slide's about the fact that like I mentioned, you can craft these HTTP requests yourself. You can go as low level as you really want on this. So if you want to be a cool kid, you're going to use Python requests or like Golang. If you're more of like a masochist, you could use Netcat. And if you just want to be edgy, you can use curl. And that's kind of how it goes now. There's actual purposes to use those things, but I was just being unnecessarily combative. So there's very, very, very legitimate purposes for curl and, well, I guess occasionally Netcat. Yeah, actually, there's some, OK. So quick and dirty, HTML and CSS. So this is what HTML looks like. If you want to play along at home, open up any random web page and just right-click and say View Page Source, and you're looking at it. So like, what makes the internet look good? So we have tags here. This is represented in kind of what's called, this is why it's a markup language. It's similar to XML if you've seen that. In fact, it's basically XML, except with a little bit more specific tags. So like here, we have a hi everyone that's in a h1 tag that's within the body tag. Don't confuse this body with the body we were just talking about. This is the body that's within the HTML. Somewhat confusing, but not the same thing. So like you're going to structure things in that manner. You just put things inside of other things and next to other things. And then you're going to use things like CSS to bring out enhancements to that. So like here we're setting an ID on this div. And then in the CSS, which is a separate file, typically, it can be within the HTML also. But in a separate file, we're defining what we want to do with any div that has the myDiv ID. And here we're setting the background color to red. So if we were to show this on a web page, this lovely div of class large objects, the background color for that div is going to be red. And that's how they play together. You have, like you said, IDs or other or classes or other things, and then CSS will put some cool stuff into it. This is what I was talking about when I was talking about the web stack. It's a very old picture. But like you kind of just build on top of things as well as like inside of other things. So like you can see in the back here, we have this giant white box, which is like this large overarching div. So div is actually a tag that's typically used for a container, like a generic container. So like it doesn't necessarily have that many properties to itself until you apply them or create them. So people use it to like organize location and like create little paddings and all this other stuff. There's also span, which does something very similar, but span is newer, question mark. So yeah, and then you see that then they put a div up here, and then they put a div on top of that, and you kind of build it's inside in the XML, but you're actually building up, depending on how you set your CSS, because you can actually, if I put like a div here in like the code, I can say the CSS, this is the Z value I want, and just put it behind other divs. So there's a lot of stuff that you can do. This is just representative of like all the shit that's going on. So Webscale 101, JavaScript. Cool. So JavaScript is a programming language, a scripting language, I should say, that runs in your browser. It's basically everywhere in 2018. There's Node.js, which is like server-side JavaScript. So it's like that fun, fancy language that all you front-end developers used to use for like front-end development. Well, now you can do it server-side. So now there's Node.js, which is it's useful. It's very useful, but it's also just JavaScript everywhere. And you can read a bunch of memes about JavaScript as a language. But runtime JS, which I believe was like an ISO kernel type thing. It was like it is, I should say. So it's like you're able to, it's kind of like Node OS, if you've heard of Node OS, which is JavaScript as an OS, and then underneath that runtime JS would be like a JavaScript kernel. Yes, more JavaScript. So interact is a very fancy word here. So like this is basically all of the movement that's occurring post population of the page, as well as like all of the back-end stuff that's occurring, as long as it's just not imports that originally were placed. So you can almost do whatever you want if you can somehow put JavaScript onto a page, because JavaScript basically has full dominion of the page that it is on. So like I could change what the page says. I could change the colors of the page. I could type things for you. I could steal your cookies, which, again, more on this hashtag soon. But remember that cookies were used as like the statefulness or like even authentication purposes. So if I'm able to steal your cookies, I'm going to have a bad time. But again, not there yet. Developer console. This is something that's in browsers that you can use to like really dive deep on all of this stuff within the browser. So there's a lot to go on with Developer Console. In fact, it could be its own presentation. But you can view the things that they say here. So you can look at the HTML. You can modify it. You can run JavaScript, view JavaScript, look at the errors of the JavaScript that has thrown. You can inspect the requests that you're making. So like, if you're not personally making the HTTP requests, your browser is making them. They're still happening, guaranteed. And you can see all of them in there. You can see the responses that the server's sending back. You can view the TLS certificate. So that's that HTTPS portion that we referred to. TLS is it's the protocol that's used to actually give you that encryption. You can view your cookies. You can do a ton of stuff. So yeah, if you want, you can pop that bad boy open and look at it when you get a chance. This is a Chrome one, but Firefox has one. Opera has one. Yeah, very useful. Very, very useful. OK, cookies. Yes, nice. So yeah, you can tell that this is a very large subject. OK, so robots.txt. So like you can put, if you're hosting a web server, you can put robots.txt in the web root. So when I say web root, I guess I've been using that term, and I haven't really defined it. So web root is the location slash where like basically your entire website is served. So yeah, usually things that are in the web root are things like robots.txt, which I'll explain in a second, and index.html. These are like the top level things in your website, and then you have folders and subdirectories and all this other, well, so yeah, inside of that. So robots.txt is used kind of as like a nice way to tell bots, hey, you can scrape this portion, but not this portion, please, please. And then you just say please a bunch of times. And like Google will respect this. So like how Google indexes stuff is that, you know, they crawl throughout the internet and they crawl different web pages. And if they see a robots.txt, they're going to parse it, and they're going to respect the, you're allowed to look at this, you're not allowed to look at this stuff. But if you write a crawler, you don't have to respect it. So it's kind of just like a nice agreement, so to speak. So HTTPS, I mentioned it a few times. So that's HTTP with TLS. If you see SSL, be a little nervous. But yeah, so SSL, so okay, side tangent about this. So it used to be SSL, and that's why if most people talk about it, they'll say SSL. And they transitioned from SSL to now it's called TLS. TLS 1.3 is the most current spec, and yeah, anyways, so if you see SSL, it might just be because if someone says it because like they're used to it, and that's what they've always said. Or they might actually mean SSL, in which case, maybe ask about that. So, like we mentioned way earlier, HTTPS is typically hosted on 443. That's the port. So when like you connect to the web server, right, you have to give like an IP address and a port. That's part of the TCP and such. So that's typically the port it's hosted on. Doesn't need to be hosted on it. That's what it's typically hosted on. And as we also mentioned earlier, if you're setting up a web server that has port 80 open, you should redirect to your 443. So that's 80 being HTTP, redirecting to the HTTPS on 443. So yeah, cool. Crypto week, yay. And now we finally get into the exploits and mitigations after we talked about that for a little while. All right, JavaScript. So I mentioned that like JavaScript is very powerful. It can do a lot of things. It can almost do everything. So one of the things that people might use it for is client-side authentication. This could be like username equals and password equals, like literally in the JavaScript. So like the reason why that's bad is because JavaScript, remember, that's sent back to you as the client. So like you can just pop open that view page source, right? And you can look directly at the JavaScript itself, and you can literally see an if statement that's like username equals admin, password equals password, and you're like, ha, got him. And then you can log in with admin password and you hack the system. That's why it's bad to do what's called client-side authentication. That's what that is. You should always send it back to the server to do authentication. So then you can't play around with that as an attacker. Form validation, yeah, we'll get on form validation quite a bit in a minute. So cross-site scripting. So how cross-site scripting works is that you're able to inject malicious or just whatever JavaScript onto a page that you don't necessarily control. So this is bad because of all the things I mentioned earlier. You can steal cookies, which again are used for authentication. So you steal a cookie, you can do whatever you want as that user. So like if this is kind of similar to how the Facebook vulnerability happened recently, how they had an access token and someone was able to get that access token, you can effectively work as that user, however that user would be. It's literally the same thing as being that person. So anything you could do with that, you could, if it's a bank account and you steal a cookie, you could withdraw money. If like it's a Facebook account, you could post as that person. You could do a lot of things. That's why it's bad. So there's two different types of XSS. There's stored versus reflected. So how stored works is that you were somehow able to inject JavaScript that was then stored as part of the website. So the next time another user tries to go to that part of the website, they will receive that JavaScript. That JavaScript will be loaded into their browser. This is pretty bad. There's also reflected, which is basically there's some user input that allows you to inject JavaScript onto a page, and then it gets back to you. So like you might be thinking, if you're able to parse the sentence that I just barfed out, that like what does that matter? Like I should be allowed to like just put JavaScript on the page I'm viewing. Like what is that? I don't even care about that. The problem is when like this is used in a chain of attacks. So like if a hacker is able to like do this type of reflected XSS at you through like say a URL. So like they just send you something to click on and it injects JavaScript into the page through that as part of the link. That's not good. Basically similar. So yeah, that's what I said. Cool. Cookie stealing. Cool. So next, exploit. Now we'll actually get into exploit mitigation. So there's CSRF, or cross-site request forgery. So how that works is that you have like, we'll say, one website that you're on that's like your go-to website. You're having a fun time. You're playing some video games or whatever. And then Nick's malicious website that you also load up because you're just curious and you're just like, I want to look at Nick's malicious website. It seems like a cool dude. So like if I am, as Nick's malicious website, able to actually do requests to your favorite game thing that you're playing, like from your browser, and there's no authentication there that like is stopping me, I'm able to do requests acting as you. So that's why it's called a cross-site, one site to another, request forgery, because I'm forging a request on your behalf Sometimes these are typically situations where you don't necessarily need to steal a cookie. It's more because people haven't set up their, we'll get to that in a second, we'll get to mitigations. So yeah, that's typically how it is. Like here, you're changing the password for someone because the first good website allowed a password change parameter that you just boop, send it, and they're like, oh, okay, sounds good to me. So mitigation. So there's a few things. There's stuff you can do with what's called CORS, cross-origin request something. Don't remember that right now. But what that basically says is that a web server can restrict who can actually send requests to your web server. And this is typically done. So okay, preface this. You might be asking, why would you ever allow requests not from your from your website? And what that comes down to is that a little while ago, people started to do like front-end development and server-side development like separately. And so they might build a web front-end or a JavaScript front-end that's served on a different port to interface with some back-end. And like in order to do that type of functionality, you need to allow another server to be able to do requests to you. And that's why CORS exists, where you can actually specify only this box or only these boxes coming from this domain or this part of the domain can make requests to my web server. Another mitigation is, and this is the one that's probably going to be expected in like an interview, would be CSRF tokens, which are basically random numbers that you plop in to a form that are submitted as part of the form, and you need to actually, as an attacker, you would have actually need to see the HTML on the other page in order to know what that token was. Fortunately, browsers silo different pages, we'll say. Pages that you visit, so that way like one page could not view another page's HTML. And some lovely frameworks actually do some CSRF stuff for you by default. Django's one of these. Cool. So server-side request forgery. So this would be an example of when, like, so as a web server, you make a lot of requests, right? You might be interacting with the database. You might be interacting with like some other internal API or AD or something, Active Directory. So in order to do that, you have to have permissions to obviously access those things as the web server. If, unfortunately, you allow a user to directly query or access those other services through the web server, then that's called a server-side request forgery. So for example, if there was a parameter that you could pass to a web server that basically does a query onto Active Directory, or even like it would change someone's password in Active Directory because your web server allows people to change their password or something, then that would be like server-side request forgery. This is like a superset of things like SQL injection, but which we'll get to in a minute, has its own slide. I'll just hold off until then to talk more about that. So mitigation is that you should whitelist. So you can only access the things you absolutely need to. So if this is a problem, then at least it's not widespread pandemonium. But you should also do request sanitization and validation. So that's a fancy-ass word that means that you're going to, when you take user input, whether that be a URL, whether that be a form, whether that be a comment section, doesn't matter, you're going to make sure that it's safe and it's not directly just going into like a request that the web server is sending. You need to like handle user input as assumed to be malicious almost. Not almost, you should do that. So you need to try to make sure that it's as safe as possible. Also, you don't necessarily need all of these different URL schemes that your web server can access. So like, if your web server is not like reaching out to an FTP server, why does it need to be able to handle FTP requests? Doesn't. So yeah. Okay, like we were talking about it, SQL injection. This is something that's very popular to teach in CSEC 101. So most websites these days have a database. Interesting. So yeah, you have a database, you have a web server, classic system. You're storing information on that web server. If you think about it, if I want to log into a web server, right? If I want to log into a website, the web server will take my request that has my username and password. It's going to do something to the password. It's going to hash it. It's going to be great. And then it's going to query a database. And it's going to be like, hello, database. Do you have a user where their name equals Nicholas and their password equals blah? And the database will either say, yeah, or it will say, no. And that can be used, I mean, that is used for authentication purposes. So if I'm just sending in a username to a web server, and they're directly putting it right in, copying it right into a SQL query, you have to know a little bit about SQL to do this, but you could effectively form your own SQL query. So here, this person is doing select all users from users where the user equals, and then what this fancy notation is it's PHP for what the user sent me. So I'm not going to get into that. But basically, this is something that you as the user send. So what could I do? Well, I could say like, oh, where the user equals, and I can close a quotation mark, so where the user equals nothing. And then I can say, or 1 equals 1. So like, or 1 equals 1, that's obviously going to be true. So then the select statement is going to return true for every single user. It's going to return all the users. And all that, and the reason for all of this is because we let a user input directly go into a SQL query. Cool. So mitigation, very similar to the previous one. Sanitize your inputs. You get something from a user, assume it's malicious. Never, in big reds here, never allow raw parameters to go into a query string. It's bad. SQL also has these lovely things called prepared statements. It abstracts database interactions into function calls. OK, that's not helpful, though. So what that does is basically allow you to just pass in these strings. And it will handle how the string gets parsed by the SQL on the back end. So you can't just inject your own logic into the string. It's going to just, escape out things for you. So, but do both, because both are good. Cool. Oh, in addition to make your life easier, right? There's things in 2018, a database abstraction layer or a object, whatever. So like, there's things like Mongo Engine, which are libraries in Python. That's a library in Python. Django has its own little models thing. So basically, you're able to write your own models, which are represented in databases tables, and provide structure to your data without having to handle all that needless SQL logic stuff. And if you make it easier for the programmer to do things correctly, then they're probably going to not mess it up as much. And that's the important part. Local file inclusion. What are we doing on time? OK. Local file inclusion. So how this works is that typically if you have like a web URL that takes a parameter, or it could just be any other part of the web server, that takes a parameter that looks for a particular file. So here we have a preview.php, and we're previewing some example.html thing, right? So we just want to see a preview of the page. This is something that vulnerable host is allowing us to do. So the problem with this is if you're not careful with how you handle this parameter, what happens if I just go like .. .. whatever, Etsy password? Are you going to show me Etsy password? Well, it just so happens if you're not careful, yes. Like you're going to be able to see any web page that the web server's user has access to. So the web server is getting run as a user and has access to certain files. So in addition to, you can use this as a chain of exploits. So like if you know that there's a file on the system where you can drop in whatever you want, say some PHP, then you can use this local file inclusion in order to view that PHP. It will run it on the back end, and it will return the results. So that could be used for another exploit like RCE, which I don't know if it's talked about in this, but that's fun. Okay, you're noticing a trend, hopefully. Don't trust user input, ever. In the URL, in a form, always handle it like it's malicious. And also, you can restrict what your web server can read. Like I mentioned, the web server runs under a specific user. That user doesn't need to have access to like that much stuff, right? Like your web server doesn't need to be root. It doesn't need that much privilege. Least privilege is important. As well as like letting a user specify arbitrary files. Probably just don't even go down that path, right? Like there's no reason for you to just allow the user to specify a file as an input. You can have them click buttons where it looks like they're specifying a file, but what they're actually doing is just hitting different endpoints, not necessarily the direct file. Command injection. So I guess we are talking about that. Cool. So here we have like the same type of thing, a read file endpoint. So and it's reading bobresume.txt. How apropos. So like on the back end, this is a Flask server or a Django server or something. And what they're going to do is that they're just going to do os.system. So for those who don't know, os.system is like Python's rudimentary way to run a command on the host system. Cat, and then file name. This is a bad example, because os.system doesn't return you output. So in theory, if this returned you output, then you could cat file name, right? And then you would get like the contents of Bob resume, because cat just returns the contents. But you know, if it's bash, you can separate a command with a semicolon and then add additional command in there. So I could do like b, doesn't matter what it is, it's going to crash, it's going to throw an error, I don't care. I'm going to end my first command, and then I'm going to do ls. So like when this gets run by os.system, or okay, we'll say subprocess, because that's another Python thing that actually returns you output. Then it's going to return to me the output of ls. And that's just ls, but you could reasonably do whatever the web server can do. So as you can guess, there's the trend again where you got to sanitize your inputs. You have to not trust users' inputs. In addition to, there's not really a good reason to like just run raw commands in most code. There's some code where it could be very useful. Most of it, not so great. So here, like for here, we're opening the file and we're doing an f.read as opposed to just calling, os.system or subprocess. Yeah. So like I also mentioned previously, there's no reason that web server needs to be run as something overprivileged like root. Not useful. Like the web server user only needs as much data as it should need. Yeah, like it's a least privileged thing. You don't want to just give it access to like PII data if it doesn't need access to PII data. Like you don't need it. It doesn't need to access users' home directories on the system. It doesn't need to access like most of these things. Tips and tricks. Like I said, most of this has to do with input sanitization. So like if you're going to do like some type of CTF or like some type of like bug bounty thing, it's important to know like what you're going up against if you're trying to find security vulnerabilities. So like things like Apache and Nginx, or I guess Node or Flask, those are all web servers. I'll say Node.js. Golang can also run a web server. PHP, we didn't really talk about it that much, but PHP is like a server-side language. So it basically works is that you send HTTP requests to the server. PHP will write HTML and CSS and JavaScript files and then lob them back at you. And that's different from, semi-different than the other ones because of like most of the logic in PHP is on the server side as opposed to, well, Apache and Nginx have no like programming, they have modules. Okay, Apache and Nginx are web servers. Node, Flask are, and I guess Golang are like ways that you can run a web server with additional logic, and then PHP is that extra logic that you can apply with like, not with those, but like by itself. It's a programming language. Okay. Yeah. So like if you find a nice little vulnerability, this is just a little tidbit. Find a vulnerability in one of these things, write an automated like script to exploit it. Maybe even put it in like some type of integration thing that you just run a lot. And then maybe you'll just get extra money later when like a bug re-pops up. So these are some resources that you can look at. So like, again, these slides will be posted, but the OWASP, so OWASP is a organization that basically runs web application security stuff. It's very, very prolific. So they have a top 10 that they update every year. So 2017 is out. 2018 is not out yet. Useful for you to look at. This basically detail the top 10 vulnerabilities in web apps in that year or in general, as well as they do a bunch of other stuff. They have great explanations. You can look at them. The Web Application Hacker's Handbook. This is a great little book. It details all of this stuff, much more detail. And then there's all this stuff. The links are here. Look at them at your leisure. They're great. So now, after all of that, we're going to go to a lovely demo time.
We are. And if you look in demo help, it's posted there now.